The requirement for protection when passing through a floor pertains to instances where the cable traverses the floor independently of a wall section. When routing service entrance cable, also known as SER, upwards from a crawl space to a load center situated on the first floor, safeguarding the cable is crucial at the point where it penetrates the bottom plate of the wall section. This stipulation arises from the classification of the bottom plate as an integral component of the floor structure. The fundamental rationale behind this regulation is to shield the cable against potential harm stemming from physical stress or impact. Acceptable protective measures encompass the utilization of conduit, raceway, or alternative methods sanctioned by regulatory bodies. To elaborate further, consider the National Electrical Code, often referred to as the NEC. This code meticulously outlines the standards and guidelines for electrical installations to ensure safety and proper functionality. Within the NEC, specific articles address the protection of cables, including non-metallic sheath cable, designated as NM cable, and service entrance cable, identified as SE cable. These cables are commonly employed in residential and commercial wiring applications. When cables transit through floors, they become vulnerable to various hazards, such as physical damage from foot traffic, furniture movement, or construction activities. Consequently, the NEC mandates protective measures to mitigate these risks. The term floor encompasses not only the visible surface upon which one walks, but also the structural elements supporting it, including the bottom plates of walls. Therefore, when a cable passes through a bottom plate, it is deemed to be passing through the floor, necessitating protection. Protection methods stipulated by the NEC are designed to provide a robust barrier against physical damage. Conduit, a rigid or flexible tubing specifically designed for electrical wiring, offers a durable encasement for cables, shielding them from impact and abrasion. Raceway, a broader term encompassing various types of enclosed channels for cables, serves a similar protective function. Alternatively, other approved methods may include the use of metallic or non-metallic sleeves, guards, or wraps that provide adequate physical protection. The selection of the appropriate protection method depends on several factors, including the type of cable, the location of the penetration, and the potential for physical abuse. For instance, in areas with high foot traffic or potential for heavy objects to be moved, a more robust protection method, such as rigid metal conduit, may be necessary. Conversely, in less vulnerable locations, a flexible conduit or sleeve may suffice. It is imperative to consult the NEC and local electrical codes to determine the specific requirements for cable protection in the given application. These codes provide detailed guidance on the acceptable protection methods, installation procedures, and inspection criteria. Failure to comply with these codes can result in safety hazards, electrical failures, and legal liabilities. In addition to physical protection, it is also essential to ensure that cables are properly supported and secured when passing through floors. The NEC specifies requirements for cable support to prevent strain on the conductors and terminations. Cables should be supported at intervals that prevent excessive sagging or movement. Furthermore, it is crucial to seal any openings around the cable penetration to prevent the ingress of moisture, dust, or pests. Proper sealing helps maintain the integrity of the electrical system and prevent corrosion or other damage to the cables and equipment. In summary, the protection of NM and SE cables when passing through floors is a critical safety requirement mandated by the NEC and local electrical codes. This protection is necessary to prevent physical damage to the cables, which could lead to electrical hazards or system failures. The acceptable protection methods include conduit, raceway, and other approved means. It is essential to consult the relevant codes and regulations to ensure compliance and to select the appropriate protection method for a given application. Furthermore, proper cable support and sealing of penetrations are also crucial for maintaining the integrity and safety of the electrical system. Now let's consider some additional aspects related to cable protection and installation practices. Firstly, when selecting a conduit or a raceway for cable protection, it is essential to choose a size that is appropriate for the number and size of cables being installed. Overfilling a conduit or raceway can make it difficult to pull the cables through and can also damage the insulation. The NEC provides guidelines for conduit fill, which specify the maximum percentage of the conduit's cross-sectional area that can be occupied by cables. Secondly, when installing conduit or raceway, it is important to use proper fittings and connectors to ensure a secure and watertight connection. Loose or improperly installed fittings can allow moisture and contaminants to enter the conduit, which can corrode the cables and lead to electrical problems. Thirdly, when bending conduit, it is essential to use a conduit bender to avoid kinking or damaging the conduit. Kinks in the conduit can restrict the flow of cables and can also weaken the conduit, making it more susceptible to damage. Fourthly, when pulling cables through conduit, it is helpful to use a cable lubricant to reduce friction and prevent damage to the insulation. Cable lubricants are specifically designed for electrical cables and will not damage the insulation. Fifthly, when terminating cables, it is essential to use the correct type of connectors and to follow the manufacturer's instructions carefully. Improperly terminated cables can create loose connections, which can generate heat and lead to electrical fires. Sixthly, when working with electrical wiring, it is always important to energize the circuit before starting any work. This will prevent electrical shock and injury. Seventhly, when testing electrical circuits, it is important to use a properly calibrated testing instrument. This will ensure accurate readings and prevent damage to the equipment. Eighthly, when inspecting electrical installations, it is important to look for any signs of damage or deterioration. This includes cracked or broken conduit, loose fittings, and damaged insulation. Ninthly, when repairing electrical installations, it is important to use the correct type of replacement parts. This will ensure that the installation is safe and functional. Tenthly, when modifying electrical installations, it is important to consult with a qualified electrician to ensure that the work is done in accordance with the NEC and local electrical codes. In addition to the above, it's important to elaborate on specific scenarios and applications where cable protection is paramount. Consider a residential setting with an unfinished basement or crawl space. Cables running along joists or through walls in these areas are particularly susceptible to damage from rodents, moisture, and physical impact. In such cases, utilizing conduit or raceway provides a robust barrier against these hazards. Furthermore, in commercial environments, where electrical systems are often more complex and exposed to heavier usage, cable protection becomes even more critical. Cables running through manufacturing plants, warehouses, or retail spaces are at risk from forklift traffic, machinery, and general wear and tear. In these situations, rigid metal conduit or heavy-duty raceway systems are often employed to ensure long-term reliability and safety. Moreover, it's worth noting that the NEC also addresses the protection of cables in specific environments such as wet locations, hazardous locations, and areas with corrosive atmospheres. In these environments, specialized types of conduit, raceway, and cable are required to withstand the harsh conditions and prevent electrical hazards. For example, in wet locations, such as outdoor installations or areas subject to moisture, watertight conduit and fittings are necessary to prevent water from entering the electrical system. Similarly, in hazardous locations, such as areas with flammable gases or dust, explosion-proof conduit and fittings are required to contain any potential explosions and prevent them from spreading to other areas. Finally, it's crucial to emphasize the importance of ongoing maintenance and inspection of electrical systems to ensure that cable protection remains effective over time. Regular inspections can identify any signs of damage, deterioration, or improper installation, allowing for timely repairs or replacements to be made. This proactive approach helps to maintain the safety and reliability of the electrical system and prevent costly downtime. The selection of the appropriate cable type is also of significant importance. NM cable, for instance, is designed for dry, interior locations, while UF cable is suitable for direct burial applications. Using the incorrect cable type can lead to premature failure and potential hazards. When routing cables, it's essential to avoid sharp bends or kinks, which can damage the insulation and reduce the cable's current carrying capacity. The NEC specifies minimum bending radii for different cable types to prevent such damage. Furthermore, cables should be supported at regular intervals to prevent sagging or strain, which can also compromise their integrity. In addition to physical protection, it's also important to consider overcurrent protection for cables. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit, preventing damage to the cables and equipment. The size of the overcurrent protection device should be carefully selected to match the ampacity of the cable being protected. The NEC provides tables that list the ampacity of different cable types and sizes, based on their insulation type and installation conditions. It's also worth noting that the NEC requires ground fault circuit interrupter, or GFCI, protection for certain circuits in residential and commercial buildings. GFCI protection is designed to detect small imbalances in current flow which can indicate ground fault. When a ground fault is detected, the GFCI trips, interrupting the circuit and preventing electrical shock. GFCI protection is typically required for receptacles in bathrooms, kitchens, and outdoor areas where the risk of electrical shock is higher. Moreover, surge protection is also becoming increasingly important in modern electrical systems. Surge protection devices, or SPDs, are designed to protect sensitive electronic equipment from voltage surges, which can be caused by lightning strikes, power outages, or other disturbances. SPD divert excess voltage to ground, preventing it from reaching the equipment and causing damage. SPD are typically installed at the service entrance of a building and at individual circuits that serve sensitive equipment. In summary, the protection of NM and SE cables when passing through floors is a multifaceted issue that requires careful consideration of various factors, including physical protection, cable type, overcurrent protection, GFCI protection, and surge protection. By adhering to the NEC and local electrical codes, and by implementing best practices for cable installation and maintenance, it's possible to ensure the safety, reliability, and longevity of electrical systems. Remember to consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with applicable codes. Also, ensure all work complies with the latest version of the National Electrical Code and local regulations. To reiterate, the protection of cables, particularly NM and SE types, is not merely a suggestion but a mandated safety measure. The NEC, serving as the cornerstone of electrical safety standards, meticulously details these requirements. Understanding the nuances of these regulations is paramount for ensuring electrical installations are not only functional but also inherently safe. When cables traverse structural elements such as floors, they become susceptible to physical damage from a myriad of sources. Foot traffic, movement of furniture, or even inadvertent construction activities pose a threat to the integrity of these cables. This is where the concept of protection comes into play. The NEC stipulates that these cables must be shielded from potential damage through approved methods, which include, but are not limited to, the use of conduit, raceway, or other suitable enclosures. Conduit, whether rigid or flexible, serves as a robust shield, encasing the cables and deflecting potential impacts or abrasions. Raceway, encompassing a broader spectrum of enclosed channels, offers a similar protective function. The selection of the appropriate protection method hinges on several factors, including the cable type, the location of the penetration, and the anticipated level of physical stress. For example, in high-traffic areas or locations prone to heavy object movement, a more robust protection method, such as rigid metal conduit, may be deemed necessary. Conversely, in less vulnerable areas, a flexible conduit or sleeve may suffice. However, the determination of the appropriate protection method is not arbitrary. It must align with the specifications outlined in the NEC and local electrical codes. These codes provide comprehensive guidance on acceptable protection methods, installation procedures, and inspection criteria. Non-compliance with these codes can have dire consequences, ranging from safety hazards and electrical failures to legal ramifications. Therefore, meticulous adherence to these standards is non-negotiable. Moreover, the concept of cable protection extends beyond mere physical safeguarding. It also encompasses the proper support and securement of cables when passing through floors. The NEC mandates specific requirements for cable support to prevent undue strain on conductors and terminations. Cables must be supported at intervals that preclude excessive sagging or movement, thereby preserving their structural integrity. Furthermore, it is imperative to seal any openings surrounding the cable penetration to prevent the infiltration of moisture, dust, or pests. Proper sealing safeguards the electrical system from corrosion and other forms of degradation. In essence, the protection of NM and SE cables when passing through floors is a multifaceted endeavor, demanding a comprehensive understanding of the NEC, meticulous adherence to local codes, and a commitment to employing best practices in cable installation and maintenance. Now, let's turn our attention to the specific context of running service entrance cable, CR, from a crawl space to a first floor load center. In this scenario, the cable's passage through the bottom plate of the wall section necessitates protection. This requirement stems from the classification of the bottom plate as an integral part of the floor structure. As such, the cable is deemed to be passing through the floor, triggering the protection mandate. The rationale behind this requirement is to prevent physical damage to the cable, which could arise from various sources, including rodents, moisture, or accidental impacts. The bottom plate, being located near the floor, is particularly susceptible to these threats. Therefore, protecting the cable at this point is crucial for ensuring the long-term reliability and safety of the electrical system. The protection method employed in this scenario should be consistent with the NEC and local codes. Typically, this involves encasing the cable in conduit or raceway, providing a barrier against potential damage. The conduit or raceway should extend from the crawl space to the load center, ensuring continuous protection along the cable's entire path. In addition to physical protection, it's also important to consider the environmental conditions in the crawl space. Crawl spaces are often damp and prone to rodent infestations, which can pose a threat to electrical cables. Therefore, selecting cable types and protection methods that are resistant to moisture and rodent damage is crucial. For example, using UF cable, which is designed for direct burial applications, can provide added protection against moisture. Similarly, using metal conduit can deter rodents from gnawing on the cables. The installation of the cable should also adhere to best practices. This includes properly supporting the cable to prevent sagging, sealing any penetrations to prevent moisture intrusion, and ensuring that all connections are tight and secure. Moreover, it's essential to consult with a qualified electrician to ensure that the installation complies with all applicable codes and regulations. A qualified electrician can assess the specific conditions of the crawl space and the load center and recommend the most appropriate cable type, protection method, and installation practices. In conclusion, running SER cable from a crawl space to a first floor load center necessitates protection at the point where the cable passes through the bottom plate of the wall section. This requirement stems from the classification of the bottom plate as part of the floor structure. The protection method employed should be consistent with the NEC and local codes and should take into account the environmental conditions in the crawl space. Consulting with a qualified electrician is crucial for ensuring that the installation is safe, reliable, and compliant with all applicable regulations.